Hey guys, sorry I couldn't be there today. Today is Unit 4, Day 5, Quadrilaterals, and we are going to take notes. I have mine printed out on a packet, so throughout the video you'll probably need to pause it so that since you're writing everything out in your notebooks, you can draw your diagrams, write what questions are being asked. So just pause it each time a new screen comes up or a new page, just so that you can take the time to write in all the questions and the diagrams, and then continue to play as I walk through it with you. For the warm up today, it's properties of quadrilaterals. So it's this whole page, and we've got our different types of quadrilaterals up here. Remember, quadrilaterals are four-sided figures, so we have all different types of four-sided figures at the top. And then what I'm wanting you to do, I know this has red dots, but what I was asking for you guys to do was put an X or just mark it somehow for each box that has this characteristic for that diagram or for that kind of quadrilateral. So like for a parallelogram, it is a figure with four sides, which all of these are because they're all quadrilaterals. So you should have an X for this entire row for each one of those boxes. For angles adding up to be 360 degrees, well, since these are all four-sided figures, remember that 4 minus 2 times 180 does give us 360, so we should have all those be marked as well. Now, all angles that are congruent, so that means all the angles are equal. For a parallelogram, that's not the case. It's the opposite angles that are equal to each other. For a rectangle, yes, they are all 90 degrees. Rhombus, it's not the case. Square, they have all 90-degree angles. And then those are the only two that have all the angles being equal. And since there is 360 degrees for the whole quadrilateral, if all the angles are equal, then yeah, 360 divided by 4 would give me 90. So it should just be these two that have the whole 90 degrees for each angle. For both pairs of opposite angles are congruent. Opposite angles for the parallelogram are those opposite corners. These opposite corners, those are the ones equal to each other. So yes for parallelograms, yes for rectangles because they're all 90 anyway. So the opposite ones would each be 90. Rhombuses, opposite angles are equal to each other. Square, opposite angles are equal to each other because, yeah, they're all 90. But for a kite, that's not the case. For a trapezoid, that's not the case. And for an isosceles trapezoid, that's not the case. For the next category, only one pair of opposite angles are congruent. So the ones we just marked, none of those will be the case because they have two pairs. So the only one that has one pair of opposite angles that are congruent is the kite. And it's these two that are equal to each other. All sides are congruent. So the only ones that are like that are the rhombus and the square. Both pairs of opposite sides are congruent. So a parallelogram, yeah, both pairs of opposite sides. These two have the same length and these two have the same length. Same way with a rectangle. Same way with a rhombus and a square because all the sides are equal. Now a kite, opposite sides aren't congruent. Trapezoid, opposite sides are not congruent necessarily. And then isosceles trapezoid, there is one pair of opposite sides that are congruent, but not both pairs. In this category said both pairs. For the next category, it's both pairs of opposite sides are parallel. So for a parallelogram, yes, both opposite sides are parallel. A rectangle is another type of parallelogram, and so yes, both opposite sides are parallel to each other. Square is the same way, and rhombus is the same way. Only one pair of opposite sides being parallel, those are your trapezoids. There's only one pair of parallel lines for those figures. Diagonals are perpendicular. So when you draw the diagonals, they would cross, there's two diagonals for each one of these. Where they intersect, they should, this is asking, do they form 90-degree angles? Because they're saying the diagonals are perpendicular. So the rhombus, the square, and the kite, those are all types of quadrilaterals where their diagonals are perpendicular. Diagonals are congruent, the rectangle and the square. And the isosceles trapezoid. Those are where your diagonals are the same length. Both diagonals for those are congruent. And then diagonals bisecting angles at a vertex. Sorry, let me reread that. Diagonals bisect angles at a vertex. So when you draw the diagonals, are they splitting those angles in half? And the only two that do that are the rhombus and the square. So if I drew a diagonal, oops, go away. And when I draw a diagonal from this corner to this corner, it's splitting that angle in half and it's splitting this angle in half. It's bisecting those angles. Same thing if I draw a diagonal going from this corner, it splits this angle in half and this angle in half. And same thing when I do it with the square, it splits them in half. And then diagonals bisect each other. So the diagonals would, where they intersect, would be splitting those diagonals in half. Pardon me. So parallelogram, rectangle, rhombus, and square. If I drew their diagonals, then where this diagonal crosses this other diagonal, then it's split it in half. So the distance for each half would be the same. And this is all information we would have gotten based off of our notes from finishing Unit 4, Day 4 notes. So that's where we're getting all this information from. That's why it's your warm-up today. So our objective today then is students will learn the properties of kites, rhombuses, squares, parallelograms, and isosceles trapezoids to find missing sides and angles. Let's not get that. I'm going to use my document camera. All right, so for our notes, we're going to start out with kite. So we're going to have a separate sheet basically, but you're writing this all down in your own notebook for each different type of figure or quadrilateral that we're working with today. So starting with kite, label your notes, Unit 4, Day 5 notes, and put kite at the top of this page. And then I want you to draw this kite out to the side here and label it with all that information. Now remember, I'm probably going to be going too fast because I have all this typed out already in front of me. You're going to end up writing these notes on your own. So take a moment, pause the video so that you can copy all this down and then restart it again, and we'll go through how to solve each problem together. So name the diagonals of the kite. So here's a diagonal going from I to E. So segment IE is one diagonal. And going from K to T is the other diagonal. So KT is my other diagonal. Number 2 says, what type of angle does the diagonals intersect at? So where the two diagonals intersect on a kite, it makes 90-degree angles right there. So it makes a right angle or a 90-degree angle. So that's the type of angles it makes where they intersect. So then they're asking, well, what's the measure of angle ICT? So going from I to C to T, they're talking about this angle here. And that's a 90-degree angle, so it's 90 degrees. Which diagonal is also the symmetry line? So remember, a line of symmetry means if I fold my image on top of that, across that line, then it'll land right back on itself over on the other side of the line. So it's symmetrical, hence the name line of symmetry. So the only line of symmetry, or only diagonal that's a line of symmetry, is this KT one. Because if I would have folded it across IE, then this is much bigger than this over here. It would not land on top of that over there. If the measure of angle CIK, so going from C to I to K, is 58, which they've already labeled there for you, what is the measure of I to K to C? So this angle here is the one they're looking for. Okay, now we know this angle's 58, and we know this angle, since these two intersect at 90-degree angles, is a 90-degree angle. Then I can find this angle because this makes a triangle here, and we know that the three angles of a triangle add up to be 180. So I can take 180 minus 58 plus 90, which gets us 180 minus 148, which is 32 degrees. Then they want to know, what is the measure of angle IKE? Now the other thing we need to realize is with a kite, since this is where it counts as a line of symmetry as well, if this angle here is 32 degrees, then this angle here is also 32 degrees. They're equal to each other. So then the measure of angle IKE, now going from I to K to E, is that big angle there. So it's including both of those 32 degree angles. So 32 plus 32 equals 64. So angle IKE is then 64 degrees. If the measure of angle CTI is 72 degrees, so they may, so they're saying C to T to I is this angle here, and they're saying that is 72. Then what's the measure of angle TIC? So if that's 72, and we know this one's 90 because it's a kite, excuse me, then I take 180, and then what the angle we're looking for is that angle over there. So I take, here's another little triangle here, so that's 180 minus the 72 plus 90. So that gets me 180 minus 162, which gives me 18 degrees. So that little angle there, angle TIC, is 18 degrees. Let me scooch that up. And then they want to know, well, what's the measure of angle TIK? So T to I to K, we know this little angle now that we just figured out is 18. And this angle is 58. Sorry, let me scooch to where you can see. So we just figured out that this little angle I is 18. We already were told that this angle is 58. So angle TIK would be this big angle combining those two. So that would be that 58 plus that 18, which gives me 76. So 76 degrees. Number 5, find the length of KI and TE. Let's see what information they've told us up here. Oh, they tell us that KE is 13.2. Now, since this is a line of symmetry, if I fold that over, then that means this side is 13.2 meters as well. So KI is 13.2 meters. And TE, well, they tell us TI is 8 meters. I know it's hidden. There's that hidden in there. Let me scooch it down a little bit. So they say that this side length is 8 meters, and that's TI. When that's over this line of symmetry, it lands on TE, so that means TE is also 8 meters. Scooch that up. So then, now that we got those two bits of information, they're asking what's the perimeter of the kite. Well, the perimeter is just adding up all the sides. So we've got 13.2 plus 13.2 plus 8 plus 8. Which gives me 42.4 meters. All right. So after you get that all down, we're going to do a few more problems dealing with kites, and then we'll move on to the rhombus. Again, if I ever go too fast, just pause it, catch up, and then start us back up again. So it says, let me give you a minute, get this out of the way. Given kite GEOM with ends at G and O. So whenever they talk about a kite, they may mention the ends. The ends are the 2 points of the kite that are the furthest away. So this is the long way of the kite. So it has ends at G and O. If TE equals 6, so the distance from T to E is 6, always, always, always label your diagram with whatever information they tell you so you can see what you're working with. So going from T to E is 6. The measure of angle TGE, so from T to G to E is this angle here, which is 48 degrees. They've already labeled it for us. And then the measure of angle EOM, so E to O to M, they're talking about this big angle here, is 70 degrees. Okay. Now, GO, they're telling me on part 1, segment GO is a symmetry diagonal for the kite. So that means this is my line of symmetry. So that means these two sides are equal, these two parts are equal. So if this is 6, then TM is also 6. And these two sides are equal. But that also means that these two little angles here are equal, and these two little angles are equal. So I know this is 48, because that one's 48. I know that this whole big angle is 70, but these two little angles are equal to each other, right? So if I just take 70 divided by 2 and get 35, then that means this little angle is 35 and this little angle is 35. Okay? So let's see what questions they asked. That was me just looking at the diagram, seeing what I can figure out based off the information they just gave me. So they said, since GO is a symmetry diagonal for the kite, angle TGE is congruent to what other angle? So going from T to G to E. So they're talking about this angle, and they're wanting to know what other angle is it congruent to. Well, we just said if that angle's 48, then this angle's 48. So our angle that we're putting there is T to G to M. All right, so that's the two angles that are equal to each other there. They tell me if the measure of angle TGM equals, well, we just figured out that it was 48 degrees because it's the same as this angle. And the measure of angle MGE, M to G to E equals what? Well, what they're talking about there is this big angle. So adding those two 48s together. So 48 plus 48 gives me 96. All right. Part 3, the measure of angle GET, G to E to T, they want us to figure that out. Well, the other thing we know about kites is where the two diagonals meet makes 90-degree angles. So those are all 90-degree angles right there. So if this one's 90 and that one's 48, then I can find this angle that they're asking for, GET. So I take 180 minus the 90 plus 48. So that gets me 180 minus 138, which gives me 42 degrees. So I'm going to label that there. That's 42. And if we know that's 42, then this little angle over here, which is identical to it, is also 42. And we know that because these are going across the line of symmetry. Now they want me to find angle OMT. So they're wanting to know this one here. Excuse me. Well, I know this angle right here is 35. That one's 90. So I'm going to use that information to help me find that. So here's another triangle. We know the angles in the triangle add up to be 180. So 180 minus that 90 plus 35. So that's 180 minus 125, giving me 55. That means this is 55, and this one's 55. Next question asks us, what's the measure of angle GMO? Well, G to M to O is this big angle, so they want us to add those together, 42 and 55. That gives us 97 degrees. Now it says, segment GO is the perpendicular bisector of what segment. So with kites, the diagonals end up becoming perpendicular bisectors. We already knew they were perpendicular because where they meet, they make 90-degree angles. But it also bisects the short diagonal. So on a kite, the long diagonal bisects the short diagonal. So that means those are equal to each other, but what they're wanting right here is it's the perpendicular bisector of this segment, which is segment ME or EM. And so they're asking, well, what's the distance from M to T? Remember, if there's no line above the MT, that means they're asking for the distance. So we already had labeled it right from the jump that the distance from M to T was 6. And the distance from M to E would be both of these added together because it's that whole distance. So 6 plus 6, which gives me 12. Okay. So that's everything we're going to cover as far as kites. Next, we're going to move on to rhombuses. Okay. So rhombuses. Go ahead and write that down. Take a moment, pause it, draw the diagram, fill in what information they already had labeled on the diagram, write out the questions so that we can fill them in together. And then when you're ready, start it back up so you can work through them with me. So they're telling us that RHOM is a rhombus. So this is a rhombus here. And it says, identify both pairs of opposite angles. So there's going to be 2 pairs that are opposite each other and 2 other pairs that are opposite each other. Now when I name these angles, I'm going to use 3 letters because we do have them broken down into smaller angles as well, so we got to be specific. So I'm going to start with this angle over here, the big angle R, so this whole thing. So it's angle HRM. And it is opposite to angle HOM. And then our other 2 opposite angles are these 2 over here. So we got RMO and angle RHO. So those are my pairs of opposite angles. The next question asks us to identify the 2 diagonals. So one of my diagonals is from R to O. So that's segment RO. And my other diagonal is HM, segment HM. And the diagonals meet, again, at a 90-degree angle. Just like the kite, the diagonals of a rhombus meet at 90-degree angles. Question 3 asks us if the measure of angle ZRH is 21 degrees. Now they labeled that on our diagram here already. That's why they have that little line there pointing to that angle. So Z to R to H is that little angle there, and they measured it, or said that it was 21 degrees. Then they want to know, what is the measure of ZRM? And also the measure of angle HOM. So ZRM, is going to be the same as angle HRZ. These 2 are going to be equal to each other. So that's a characteristic of rhombuses, is that their diagonals do bisect the angles. So ZRM is also going to be 21 degrees. And then angle HOM. Now, if this is 21 and this is 21, then across the way, these are also the same number of degrees, 21 and 21. So angle HOM is going to be adding the angle HOM is this big angle here. It's the combination of these two smaller ones. So that's going to be that 21 plus 21, giving us 42. Okay, question number 4 asks, knowing that the diagonals of a rhombus bisect a pair of opposite angles and intersects at a right angle, find the measure of angle RHM. So let's look, RHM. So they're wanting to know from R to H to M is this angle here, okay? So we know that this angle is 21. We know that this angle is 90. We need to find that angle. And we do have a triangle here. So use what you know about triangles, how their angles add up to be 180. So we're going to take 180 minus 90 plus 21. So that gives me 180 minus 111, giving me 69 degrees. So angle RHM, I'm going to go label that 69 degrees on my diagram because I always like to have all my information on my diagram as well. And what we know then is, remember, on a rhombus, the diagonals bisect the angles, the vertex of the angle where they meet. So if that's 69, then this is 69. And across the way as well, these are both 69. So now we know all the angles. So down here they're saying if, for number 5, if the distance from R to H is 9, so immediately I'm going to label that on my diagram. So if this is 9, find HO, here I'll look at you see so you can write down. Find HO, OM, and MR. And what we know about rhombuses is that all their sides are equal. So all these sides of that quadrilateral are the same. So HO is 9, OM is 9, and MR is 9. So it's like a tilted square is what I always think of with a rhombus. So all those sides are equal to each other. So let's go write that down. So HO is 9, OM is 9, and MR is 9. All right, let's do another example of a rhombus. And then we'll be done with do this, and then we're done with the rhombuses for today. And rhombus REJD, I can't talk, REJD, measure of angle DRE, so D to R to E is this big angle here, is 82. And then it says find the given angle measures. All right, so if we know that's 82, and this diagonal bisects that big angle R, these two little angles would be 82 divided by 2. So that gives me 41. So that means this is 41, and this is 41. We also know that the opposite side of the rhombus would have the same measure of angles. So that means this one's 41, and this one's 41. We also know that the two diagonals are perpendicular bisectors, or are perpendicular, so they make 90-degree angles. So we know that's 90, that's 90, that's 90, this is 90. So we'll be able to find these other ones here as well. So let's figure out what they've asked us for to begin with. So measure of angle DRA. D to R to A was this little 41 right here. The measure of angle RDA, so R to D to A, that one we got to find now. So we have a triangle here. We know that the triangle adds up to be 180. So 180 minus 90 plus 41. So it gives me 180 minus 131, which gives me 49. So that's 49, which means this little angle here is 49, and these two little angles over here are both 49, because that's characteristic of a rhombus. So their next question is, what's the measure of DJA? D to J to A, we said, is 41. And the measure of angle DJE, well, that's this big angle. Both of those added together, 41 plus 41 gives me 82 degrees. Okay, so that's how we got all those. Again, if I went too fast, pause it, rewind, do what you got to do so that you get all the notes, and just make sure you understand how we got these. Again, all these characteristics should be in your Unit 4 Day 4 notes that we finished up as homework, because we didn't have time to get to them in class. So we should have all that information in our notes. All right, let's move on to isosceles trapezoids. So those are a special kind of trapezoid. Just like an isosceles triangle has two sides that are congruent to each other, so does an isosceles trapezoid. Their legs are congruent to each other. And the legs are always the two sides that are not parallel to each other. So those are going to be your sides that are equal in length. So our base angles, take a moment, write all this down, draw your diagram. Now we're going to identify our base angles. So our base angles are always going to be the two bottom ones that are where the legs meet the longer side, the longer parallel side. So in this case, angle P and angle Q are our base angles. And just like what we did with an isosceles triangle, we drew to the opposite angle. I always think of these little lines as showing you, aiming to which angle that we're identifying as the equal angles. So angle P and angle Q are our base angles. So those are going to be the ones that are equal to each other. And that says, identify both pairs of same side angles. So same side angles are, remember when we were talking about when we had parallel lines, let me draw this in pencil, and a transversal, and we talked about the parallel line theorem. So here's my parallel lines, because with a trapezoid, these two sides are parallel to each other. And if you think of this as a transversal, a line cutting through those parallel lines, then same side angles would be this one here and this one here. Those would be same side angles. So we've got that pair, so angle P and angle S. And then on this other side, again, think of these as these are your parallel lines. Here's your transversal. Let's draw a little square here. These would be your same side interior angles as well. So angles Q and angles R. Those are my same side angles. Now, what we know based on the parallel line theorem is same side angles add up, same side interior angles add up to be 180. They are supplementary. So keep that in mind when we're figuring out our information here. See, it all builds on each other. I'm just going to erase these now. That's why it's so important to always make sure you have a good understanding of everything we learn, because we keep building on it. All right. It says identify the non-base sides. So those are the legs that I was talking about and that are equal to each other. So our PS and our RQ. And the question is, are they congruent? Yes. When you're talking about an isosceles trapezoid, those are the two sides that are congruent to each other. All right, so they're going to give us some bits of information. We're going to find out other information. So if they say the distance from S to P equals 9, then what's the distance from R to Q? So they're saying this distance S to P is 9, and they want to know this distance R to Q. Well, we know they're congruent, so it's also 9. Question number 5. If the measure of angle P is 60, what's the measure of angle Q? So angle P being 60, this is a base angle. That means this base angle is equal to it. Now that's only true of isosceles trapezoids, not of just other types of trapezoids. So it's same concept as with an isosceles triangle. This side's congruent, points to this angle. This side's congruent, points to that angle. So that means these two angles are equal to each other. So if angle P is 60, then angle Q is 60 as well. Okay. And then last but not least, number 6, it says, what is the measure of angle S and the measure of angle R? So using what we know about same side interior angles adding up to be 180 because they're supplementary, then I know that if I take 180 minus this 60, that gets me angle S. So I'm going to write down the work down here, although I know I can do it in my head. But 180 minus 60 gives me 120. So angle S is 120. So I'm going to mark that up here. And then over here, since this is 60 as well, and we know these two add up to be 180, it also has to be 120. So label it on my diagram and label it down here for the answer. Okay. All right, we're going to answer just a couple more questions about isosceles trapezoid, and then that will be the end of our notes for the day. You will have a homework assignment, and don't forget about your closure, of course. Turn in your closure to the warm-up closure bin, so I can take that for a grade, and then I will check your homework come next class. All right, so draw your diagram, label the information, make it big enough to where you can write those letters and numbers in there for your labels, and then we will work through these problems together. It says, look at isosceles trapezoid below. Oh, so it's an isosceles trapezoid, and by looking at it, that means we know these two sides are parallel lines. So it has to be these two sides, that two legs are equal to each other. All right, so it says if angle Z and angle D are same side angles, so we're talking about this and this, what is the value of X? Well, since they're same side angles, think of that parallel lines theorem, same side interior angles add up to be 180. So that's how I got to set up my equation. If I add these two up and set equal to 180 and then solve for X. So I'm going to do that out to the side here. We got 3x minus 13 plus 6x plus 4 equals 180. Combine your like terms. I've got 3x's here and plus 6x here because the sign to the left of it always goes with it. So that gives me 9x. And then we got minus 13 here and plus 4 there. So negative 13 plus 4 gives me a negative 9. So minus 9. Bring down the equals 180. Get your x's by themselves by adding 9 to both sides. And then to get x by itself, divide by 9. We get 21. So x equals 21. That's what they asked for, so I'm done there. We're talking degrees because these are angles there. So you can put the degree symbol with that. All right, so we know that x equals 21 degrees. Now they're asking, well, what's the measure of angle I? Okay, looking at our diagram, excuse me, we know that these two base angles are equal to each other. We also know that these two angles are equal to each other. Because remember on our last diagram, we got 60 and 60 for those, which means these are each 120. So if these are equal, then angle I would be represented by 6x plus 4. And we know that x is 21 now, so we replace that x with 21. So 6 times 21 plus 4. 6 times 21 gives me 126. Add 4 more to that, and we get 130. So angle I is 130 degrees. So I'm going to go ahead and label that on my diagram. So that's 130, which we know, which means this one's 130. And then they want to know measure of angle O. Well, angle O is the same side interior angle to this angle I. So we know that together these two add up to be 180. So if I just take 180 minus that 130, I get 50 degrees. So angle O is 50, which means this angle Z is also 50. Okay? Now they're asking, what's the value of Y? Well, notice we know this side, leg is equal to this leg, and they have representations for those sides here. So we've got 4y plus 8, and we've got 6y minus 18. What we know about those two legs are equal. So that's how what I do. I set those two expressions equal to each other. So 4y plus 8 equal to 6y minus 18. And then just work towards getting my y's all on one side. So I'm going to subtract 4y from both sides. You could have subtracted 6y from both sides. It'll still work. So we get 8 equals 2y minus 18. Now I got to work to get those y's by themselves. So I'm going to add 18 to both sides. So we get 26 equal to 2y. Divide by 2. And we get y equals 13. So y equals 13, and now they want to know the length of ZD. Well, ZD was represented by 4y plus 8. That's the length, what this side was represented by. So the distance from Z to D was 4y plus 8. So I'm going to write that on my paper, and now that we know what y is, that it's 13, I can replace that y with 13. 4 times 13 gives me 52. 52 plus 8 gives me 60. So the distance from Z to D is 60. So if that's 60, technically we know then this side is 60 as well. But they didn't ask for it, but we know it. All right, I'm going to put that up there. So make sure you get all the work down. Don't just put the answers, because then when you look back at your notes, you're not going to understand how you got that answer. Always write down all the work. If you missed anything, my notes are on It's Learning as well. You can always re-watch this video and catch up on it again, get a good explanation for me from it. Otherwise, you need to do your homework. The key is on It's Learning, to where I have every other problem answered. So you can do it along, have that open while you're doing your homework. Make sure you're getting them right. And enjoy the rest of your day. Homework's due next class. Make sure you get your warm-up closure turned into the bin. Thank you very much.